Hey, welcome data management folks. This is first of a bunch of review lessons, and this is on Unit 1, which is on 1 and 2 variable stats. The way these lessons will go is I'm going to try and go quite quickly through these things, and certainly the examples that you see aren't a complete picture of all the stuff that you're going to be asked for on the exam, but there'll be typical questions from the units with typical ways to approach these questions, even though there'll be lots of different possible ways to approach them. I'm going to show you sort of the most straightforward way, I suppose you could think that way. The topics you see here. Oh yeah, and you don't have to copy this. Hopefully there's a PDF version of this that you can print and then just write your notes on top of it. So like I said, I'm gonna try and go quite quickly through this. There you see the topics in 1 and 2 variable stats. This is actually chapter 2 and 3 from the text. 2 and 3 from the text, and you see all of them. Included in here is a bunch of definition type stuff. You'll see all these definitions, and there will be some definitions on the exam, not necessarily a whole bunch of stuff that it says define what it means by bias or define what it means by cause and effect or reverse cause and effect, but those definitions you are responsible for. What I'm going to show you here is a couple of typical examples from this chapter. Now, a little bit of a story about this. All these examples came from a couple of years ago. I asked my data management class about what kind of theme they want for their review, and it was a second semester thing, and all the drama at the time was the prom committee wanted to have horse and buggy rides available or included in their prom ticket price, and so there was a bunch of drama and everyone was angry or excited about this, and so you get to enjoy horse and buggy questions for your review. So anyway, let's get through it. Typical question here: when students bought their prom tickets, everyone was asked how much would you be willing to pay for a handsome cab ride to prom or at prom? And there was the data. So this is the idea of, 34 people said they'd be willing to spend $10, 12 people said they'd be willing to spend $30, and so on. There's the data. What type of data is this? Well, remember, this is part of those definitions, and this is one of the ways that I could ask you to know your definitions is, well, what type of data is this? Well, it's numeric because it's numbers. It's continuous because you could have decimals, right? You could say I'd be willing to spend $12.37 rather than discrete data, which are only integer values. This is group data, which we'll talk about soon. And it's also primary data, primary because the researcher collected this themselves versus secondary data where you find it from the internet and someone else researched that. What type of sample is this? Probably a census sample, since the key word there is everyone. And when you say census, that means the target would probably be NWSS prom people, prom goers, right? Rather than teenagers or Northwestern students in general. We're talking about just Northwestern prom goers. What type of question was this? It's hard to tell, right? Because if that was the question and this followed it, then it would be a closed checklist. But the way it's worded, it looks like it's an open question. But as we'll talk about in a second, it looks like maybe this was the technique and there's some bias involved in here. Explain how the data were organized in the table. Well, there was class intervals, wasn't there? You can kind of tell because these values, there would be an incredible coincidence that 12 people said they'd spend exactly $30. Probably that's a range of values, and we've just rounded to the midpoint here. So probably these are the intervals, right? 0 to 20, where 10 is the midpoint, and so on. Sources of bias? Well, it could have response bias. Remember, response bias is if people lied about how much they would actually spend. They exaggerated, that said they really want this to happen, so they'd spend a lot, for instance. That's response bias. Non-response bias, remember, is when people choose not to respond. That's different, and it's easy to mix up because response bias, non-response bias is when people don't respond. Measurement bias is when the surveyor has done something weird, right? The surveyor has done something weird, and I think that's the case here, because if you look at the data, this first value has 34 in it, and I'll bet you a lot of those people said 0, right? A lot of those 34 people probably said 0, and so if it was just like this, they'd have to check that one, even though when they checked that interval, it would have been rounded up to that they would be willing to spend $10. They should have probably done something like this. I'd be willing to spend 0 or somewhere between 0 and 20, and had those as separate categories. That's an example of measurement bias because the surveyor sort of messed that up. Cumulative frequency polygon. Cumulative means adding up, running total. That's what cumulative means. And remember how we do a cumulative frequency polygon is we add another column to our table that's got the running total. So up to there's 34, and then I add 34 and 12 is 46, and so on. 74, I've got the numbers here, 82, 88, and 90. And remember, a polygon is like the dot to dots, okay? Rather than a diagram is the squares, or the rectangles like this, right? That's a diagram, that's a polygon. So I'll show you my good copy in a second, but we have to remember that. Remember, another one that you can be asked for is a relative frequency polygon. And relative frequency polygon is common because it's like a percent, right? Relative frequency we later thought of as a probability distribution, right? And that's a good one for an exam because it brings in a second concept of probability, which maybe we'll talk about in later review examples. So I'm going to show you my cumulative frequency diagram. Remember that if going too fast, pause the darn video, okay? Looks like I made a little error here. 20, 40, 60, 80, 100. That should be 120. Cumulative frequency along the y-axis. X-axis is whatever's in first in the table. And cumulative frequency is this one that always goes up. And I can see how many people were surveyed as the last value. Okay. Yeah, that's it. And remember, polygon is the dots and sticks joint rather than the rectangles. Okay, the last thing that we were asked to do for this first example is to calculate all values of one variable stats. So, that's, mean, median, mode, standard deviation, variance, if you can remember that, IQR, etc., 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 range, maybe, all values. And probably what you're going to do is you're going to use a graphing calculator, right? And so you got to remember how to use the graphing calculator to do this. Turn it on, first of all. Remember, you hit stat, wherever it was. It might have been some other garbage on there. Stat, edit. And then I've already put the data in here, right? Your X values go in list 1. The frequency values go in list 2. And then we have to do one var stats, list 1, comma, list 2. So out in the normal mode, I go stat, calc, one var stats. Remember, if I just press enter, it's not going to use the group stuff, so I've got to go second, list 1, comma, second, list 2, press enter, and then there's most of the stuff. Right, I see the mean was 38, and I can copy all this stuff down. In fact, what I'm just going to do, because, well, I'm lazy, is I'm going to copy this, and put it in here. But the only thing we need to calculate from this is maybe the IQR. And I'll remind you of that. Go down here, get the rest of the goods. There we are. Lovely. And so on the exam, you'd say something like from PI 83, I used one var stats, list 1, list 2, and then you'd start just listing off all the stuff, okay? All the stuff that's important. Since it's a population, you're going to use that standard deviation, right? In fact, I should use the mu instead of x bar. It's 38 because it is population. We said it's everyone. And dollars, this is dollars that they're willing to spend, and so on, right? The variance is that squared. Variance is 27.1 squared. You can just calculate that. The one that I wanted to mention for sure is the IQR, which is just Q3 minus Q1. Q3 is 50, Q1 is 10, so the IQR is 40, right? And I just got that from right there. Easy peasy. That's it for one variable stats. I'm going to pause the video and we'll regroup for the two variable stats example.